You use this Euler reflection formula, but you don't know how to derive this. Let me show you. This is the most first definition of the gamma function given by Leonhard Euler, which shows a generalization of the factorial function. From here, find expression for gamma 1 minus z, and multiply both of the expressions. Apply the identity of plus b minus b and separate the limit like this. Now divide the numerator and denominator by square of n factorial. Rearrange the term of this first limit and solve this second limit, which is equal to 1. Here, changing this limit form to the product form, we got this expression. And now the question is that how to calculate this product. This is very well-known famous product, but here, I will derive this product for you. Let's first draw the graph of sine x. We can see that all n pi, for n belong to integer, are the roots of this curve. So we can write this function sine x in the form of multiplication of its roots, and after simplifying it we got this expression. Now put x equals to pi z and rewrite this. Also changing this expression in the product form, we got this famous product. Or we can write it like this after flipping the fraction. Now substitute this result to prove the Euler reflection formula. And from here we got our final expression of the Euler reflection formula for the gamma function. Keep learning and don't forget to subscribe the channel for more mathematics.